Okay, so we're going to find the area of the region bounded by these two graphs. We're supposed to draw a figure, shade the bounded region, and set up the integrals as needed. Use your calculator to find the answer. So we can, we could graph these on our calculator first, but let's talk about we pretty much know what these graphs look like without doing that, or we should. Without graphing anything on the calculator, can anyone tell me what the graph of x to the 6th would resemble? A parabola, good. Those power functions, if it's x squared, x to the 4th, if it's just x to some even exponent, it's going to look like a parabola. So x to the 6th looks something like this, okay? Then, so this is f of x. Then we have g of x, which is a line, right? We have a y-intercept at x equals 2. And so then it looks like something like this. Right? And then we can figure out the actual points in a minute, but it looks something like that. We good enough on that? So I need to know what A and B are. And I can, that's the area that I'm looking for. I can do this by hand, but it tells me to use my calculator. So we're going to set this up here. So if I do the integral from, we're just going to write it all out first before we even need our calculator. And we can go from, because it doesn't give us anything else. Yeah, we're going to go from A to B. And then what am I integrating? Which one goes first? The top, x plus 2. Okay. So what I can write, since I get to use my calculator, I can say g of x instead of x plus 2. Either way is fine. G of x minus f of x dx. Now, when I use my calculator to find a and b, then I need to write down what they are. So I need to say something like, let a equal and let b equal, and then we're going to store them in our calculator. But when I just have an A and B, I have to show that I actually found a number for it, and there's no magic happening. So let's go to the calculator. And so on, 1 for new, no, unless you just want to. Add a graph. So in F1, I will put, x to the 6th. And then in F2, I will put x plus 2. Now on my paper, because I have to flip back and forth here, I'm going to put that this this right here, this is what I put in F1, and this is what I put in F2. Therefore, when I come over here, this is F2 minus F1. Do you have to write anything I wrote in orange over here on the right? You don't absolutely have to, but you probably want to so you don't get things backwards, right? And it's totally fine. Now, in here, I can't write F1 and F2 because that doesn't make sense for the question, but I'm just sort of labeling it for myself. You with me on that? Okay, so now I need to find, bless you, I need to find these points of intersection. So do we know how to find points of intersection? Yes. Menu, analyze, intersection. Y'all are experts. Okay, so I'm gonna, I'm gonna run over here, enter. Okay, so now that one came out pretty. I don't necessarily have to store it, right? I can, but it's literally just, is it -1 or 1? -1. Okay, so it's really just, A is at -1. So I could even put a -1 here instead of A if I wanted to, but I already put the A, so I might as well just leave it. And again, you can store it if you want to, or you can just put the -1. It doesn't matter. Then I need to find the other intersection, right? So I'm going to do menu, analyze, intersection. I'm on the left there, and then over there. Now this one, I need to store, or I have to store, right? Am I storing the 1.2 or the 3.2? The 1.2, because it is the x value. So remember, I'm just going to put my little hand over it. Looks like I'm going to grab it. Variable. And then I called it B, So I think I want to store it in B. Oh, okay. Uh-huh. Like you're here, then you hit variable. And then you don't have the store variable option? Okay. Okay. We all good then? Okay. And so, okay, I don't think I actually stored it. I'm going to store it in B. If you don't see the same numbers I do with the same number of digits or anything, you need to let me know because we need to fix some settings in your calculator. That's different? Okay. All right, so let's fix that. So we're going to go to menu. We're looking at our graph. I want you to go to menu, 9 for settings. Here's what you want to make sure happens, because this might be part of your issue too, Carolina, on these checks. Make sure it says float 6, and then make sure both of these things are checked. That gets you less stuff on your screen. But then before you press OK, you probably have a choice that says make default. If you have something that says make default, make sure you click that so it'll stay that way. Okay? Everybody with me? Float 6. Make sure both of those are checked. If you have a make default, make sure you hit make default. We all good now? Okay, so now while we're doing this, we're going to check one other thing in a different part of the settings that doesn't affect this necessarily. I want you to hit, and then we'll come back and finish this. Hit on, 5 for settings, 2 for document settings, and then make sure you have float, not float 6, just float right here, and approximate right here. Those are the 2 most important things. And then make sure you hit make default. I don't have a make default, but most of you do because you have a different version of the calculator. That way we're getting the correct number of decimal places. On the graph, it semi-matters because you're going to write the decimals down. You're not going to type them back in, but on the graph, okay, so once you do that and you're back here, and we want to get back to where we were, just 4 for current. You go back to where you were. We're storing this number, right? But if we weren't storing it, this number was our answer, and I didn't see at least 3 decimal places, that could be a problem. And if this was more than a 1-digit number before the decimal, you may not see that if you didn't have it right. Or you might have it float, and you might see so many that there's stuff all over the place you can't read anything, so we just want to make sure it's useful there. All right. So did we all store this? We're good? Okay. So then over here, 1.214. Okay. So then I'm going to write let B equal 1.214. And because I have these 2 things written, leaving this with an A and B, totally fine. Okay? Everybody with me so far? Okay, so now we're going to go back to the calculator, and we're going to actually integrate. So I'm going to do Control, add a page, so I can add a calculator. And then we want an integral, so I'm going to hit this little button next to 9, choose my integral. Now, I didn't store -1 in A, so I have to actually type in -1. But I did store B, so I need that to be B. And then, what do I put in here? F2 minus F1. Okay, good. So F2 of X, and then get on the other side of it, minus F1 of X, and then make sure you do your dx like so. On here? Okay. We can look at that. We good? Okay. So then my answer here is 3.966 or 67, but I would just write the 3 and not try to round so that we don't do something ridiculous with rounding. You can write 4, you can write 5, it's fine. All right, what questions do you have? You good? Okay. So we're going to do settings. We want this to be float 6. And then we want this to be automatically hide. That way you can see, there'll be less mess on your screen too. Apply, okay. And then you shouldn't have to do that again. Is that better? I think it still says, oh, there you go. There you go. Okay. All right, everybody else good? Yes, yes? Okay. All right, so let's look at the next one. We do not need our calculator for the next one. This says set up, but do not evaluate. An integral expression that can be used to find the area of the region bounded by this graph. And it's drawn for me, okay? I have y equals x cubed minus 6, and I have y equals 8 minus 3x squared. So I can identify the parabola for sure. It's right there, which means that then this is my cubic function. Okay. Now, I want the area bounded by those two curves. I have this area and I have this area. When we do this, we're supposed to do top minus bottom, right? Well, which one's the top one? You sure about that? It's the top one here for this section. Is it the top one for this section? No, that changes, right? So because of the way that they are related to each other, we have to do it 2 different times. Does that make sense? Because it depends on which part. So basically we have to do it in 2 parts. We're going to look at part A here and part B there. Okay? It's a semi-trick question. It was kind of a trick question, yes. All right, so we are going to, we're going to do this first part right here. So I'm going to integrate from where to where? Where do I start? -4 to -1. And since these aren't called f of x and g of x, I have to actually write these out. Okay, and then, so this is going to be, which one's the top one here? The x cubed. Okay, so I got x cubed minus 6x minus 8 minus 3x squared. Did I write that correctly? No. I need parentheses here. I had more than one term. That makes a total difference. And I cannot forget my dx. Okay? Everybody good with that? Then I have part 2. This one right here. So I'm going to integrate starting where? -1 and going to 2. And then which one's the top one here? The 8. Okay, so 8 minus 3x squared minus the other one, which is x cubed minus 6x. Don't forget your dx. Now, we've written down part 1, part 2. What do I do with those 2 parts? Add them together. We're done. Okay. And whether we had to do this by hand or on the calculator, we're definitely capable of doing both, right? That's why it's just like a setup and don't solve, because if I simplified that, that's a polynomial. It's not that big a deal. Okay. Everybody good with all that? Okay. So now we got another one on the calculator. R is going to be this region here on the right, and we're going to find the area of R. And so the region, R is that thing that kind of looks like a triangle, but it's a curvy triangle, so it's not really a triangle. That part right there. Okay, so in order for us to identify the pieces, we get to use our calculator anyway. Let's go ahead and graph this. So we're going to start from scratch on, new, no. We're going to add a graph. So I'm going to just type them in order there. So the first one is 2 to the x power. Then 4 to the x power. Then 1 over x. my goodness. Okay. Yeah, pretty sure it was a door, but yeah, it's pretty close, I think. Okay. So that's what I got. Is that what y'all got? All right. So do you see where the three functions intersect? Yeah. Do you think we need to fix our window? Yeah, I think so. So this right now is going from 0 to 10. I don't think we want to go, we don't even need to go past 1, do we? I mean, maybe go to 2. We can go to 2. And then up here, 1, 2, 3, 4. Let's go from to 2 and 5. That sounds good, right? So, because we don't have, if they gave us something on the graph, we can do that. We don't really have anything. We're just kind of going from what's on here. So let's go to our window, menu 4, window settings. Because at this point, I don't really just want to zoom in and out. Like, I think it's better to actually do something. But I know I don't need it to go any less than 0. So what do we say? We'll go to 2, and then Y will go from like 0 to 5, maybe. I think at least we'll be able to see stuff better. We can always go back and adjust it if we need to. Everybody good with adjusting that on your own? Okay, well, it's that part right there. Which maybe I did need to go on the other side, but maybe I didn't. Can't really tell, right? Feel like maybe we need to adjust that a little bit. Maybe we adjust that menu. Let's go to, what is it, 4. My X's, let's just go from negative 0.5. We don't need to make it a lot. Oh, wait. Yeah, that's what I want. One of my X's. There we go. That way we can make sure that we know what's going on. And we could zoom in more, but it's really not necessary. I can see what I need to see. It's fine. Okay, so I'm going to go back over here. I'm going to say, well, I put this one in F1, this one's in F2, this one's in F3, just kind of for myself so I don't mess anything up. So what's the title of these notes? Between how many curves? 2. How many curves do we have here? 3. We can only do this between 2, so we've got to adjust this somehow. Do you see how maybe I could split this region into 2 different regions? What if I went here where these intersect and I dropped a line straight down? It'll never be straight on this board, you can pretend. Straight down like this. And then I have split it into this region and this region. And so this right side is using 2 curves and this left side is using just 2 curves. You see how that works? But I would need to know what this X value is right here. Can I find that? Yes, the intersection right here. If I find where these intersect, that gives me that X value, right? Okay, so now we have 3 curves on here. Here's what you got to pay attention to when you have 3, because we know how to find intersection. When I go to menu, 6, and intersection, the first question it asks me, notice I don't get a left and right bound. It's asking me which graph, like which graphs are we trying to figure out the intersection of. So I'm going to choose that one, and I'm going to choose the other one. Bam. And now that I have them chosen, it's going to ignore the blue one, and then I can actually find the intersection here. Do I need to do that again? No, we're good? Okay. All right. So here, that's at 0.5. And because my settings are correct on my calculator, I'm confident that it's actually 0.5. You with me? If the settings were different, I'd be like, I don't know, maybe I need to store it, but it's 0.5. Okay, so I can mark this at 0.5. Everybody okay with that? All right, so what else do I need to know? I need to know this part right here. See if that really is, it looks like it's a 0, but we probably need to check that. And I need to figure out this part, right? I need those points. Okay, so let's go back over here. And we're going to do this again. So menu, analyze graph. I want the intersection again, and it's asking me which graph. So now I'm going to do the red and the blue. So I'm going to choose the red. Now I'm going to choose the blue. And then I'm going to find my intersection and just assure myself that it's 0, and it is 0. Okay? So this is at 0. Then we'll do it one more time for the other one. Menu, 6, 4. I'm going to choose the black and the blue this time. I'm trying to choose the black and the blue. There we go. Okay, so that one, not so pretty. What should I do with that? Store it. So I'm going to store it. Variable, let's call this one what? B, since it'll be the second one, that's fine. B. So I'm going to let B equal 0.641. Make this B, we can say let B equal 0.641, something, something, something. Okie dokie. So let's set this up. We are going to integrate, so this first part here that we're going to do in purple, we're going to find this region. So we're going to go from 0 to 0.5, and then I need the top minus the bottom. Which one's the top? Do you know? Okay, so if you are not sure, when I look at this, it's the red one, right? So if I hit tab, and I go up here, I can see my colors, right? There's the blue, the red, and the black. So I can go back and label. So F1 is blue, so that's the bottom one, then F2, then F3. So this is F1, this is F2, and this is F3. So in this first section, when I want F2 minus F1, that is 4 to the x power minus 2 to the x power, which I can label as F2 and F1 for myself, so I can put them in the calculator. And then I got a dx. Then I'm going to have to do this other part, right? So I'm going to add to it. What's my bottom limit for my integration? 0.5. What's the top one? B, yes. And then this top function, top minus bottom, that is going to be 1 over x minus 2 to the x dx. And then you have options. So your options are when you integrate, you can retype in the exponential part if you want to, but you can also do the F1, F2. I think that might be a little bit safer. Any questions at this point right here? We all good with where everything came from? All right, so let's go put this in the calculator. We're going to add a page, add a calculator. So I'm going to integrate. There's my integral. I'm going from 0 to 0.5. Then I'm going to have F2 of x minus F1 of x dx. And then I want to add to that another integral. Just go ahead and get it all typed in. What did I do? Oh, I didn't store mine because I don't think I stored. So when that happens, that's bad. Is that what Marcel did to me? I'm with you, dude. Okay, so I'm like, dang it. I was so careful with everything. So I'm going to go back. I did not store it. See, it's not bolded. That's what tells me I didn't store it. So I'm going to try to hover. Oh, I need to escape out of that. There we go. So I'm going to store it. in B. Now watch this, Marcel, because we're not going to have to type everything back in, because that would be a nightmare. Okay? And the rest of y'all watch too, because this kind of stuff could happen to you. Now that we got it stored, we're going to go back over here. Now, I definitely don't want to have to type all that back in. If I arrow up and it's blue and I hit enter, it pops it back down there for me. And then, bam. Okay. So if I okay, 2 reasons you might want to do this. Let's say I messed up, like I just did. Or let's say I'm using basically the same thing, but it just changes the limits of integration or something. And so I don't have to retype it. If you arrow up, whether it's there, or it's arrowing for me anyway, because my board jumps around. They're the same anyway, but you can arrow up as far as you want to go. Once it's highlighted in blue, wherever you were, you can hit enter and it pops it. Then you could go edit it if you needed to. You could arrow over and edit or do whatever. Okay. Let me ask you this. On the test, did y'all store it in like FRQ1 and FRQ2? Did anybody do that? No? Would that have been helpful? No? Okay. Just curious. Like you didn't go back or anything? Okay. Okay. All right. So we're good with that? Then that's our answer. We got, this is I don't even have the answer written down. 0.1627. Okay. We good with all that? Any questions at all? All right, let's see. I know we're not going to get very far on the next one. Well, let's just talk about it. We don't necessarily have to do it. But this would be the same type of thing, okay? Sort of. I do have 2 curves, right? I have 2 curves, but it's not really the area between, there's not really a top and a bottom. There's more like a left and a right. So I still would have to split it right here. Okay, so that I have 2 regions. But when I do that, now it's just area under the curve and area under the curve. Does that make sense? So you're just integrating. You're not integrating and subtracting anything. Okay, so that's another kind of way to do that. But we have a few minutes. We can get this done. So we're going to find that area. We already know it. We know what that's at 4.2, so we're good. I was thinking we still have 5 minutes. We can get this done. So I'm going to integrate from 0 to 4. Right? And I'm integrating the square root of x, because one of them is a line, and we know that that's not a line, dx. Because, again, it's just straight up area under the curve. And then I'm going to add to that the integral from 4 to, 6? Of 6 minus x dx. The second part tells us to deal in y's. So if I did it sideways, remember how we talked about, yes, we can do it in terms of x, but we could also do it in terms of y's. We talked about that the first day, and then we were looking at y values. If you did it around the y-axis, then you could do a top minus the bottom if you had it in terms of that, which, I don't know, we wouldn't necessarily have to, but we're going to look at that with some rotation stuff that we're going to do next week. We're going to play with Play-Doh next week. For real. Yay. Okay. So we're good for today. Continue trying.